Woo! It's time for a little chapter 8 review. Does that sound good, Mr. Ernst?
Wonderful.
It sounds wonderful. That's why I'm masked up, in a room with somebody else. But we're all going to learn some honors geometry here, review some honors geometry. Alrighty, so we've got this first problem here. DE is parallel to CB, and the lengths on and we got the lengths on the diagram there. All right, so we got 12, 16, 8, 20. Wonderful, fantastic. We want to find EB and CB. Now, I think right off the bat here, you know what I'm going to do is I'm going to label EB as X, and we'll go with CB as being Y, just to make it a little bit easier as I'm setting things up. And I'll jot that down underneath these. There we go. Okay. So if I've got parallel lines, that tells me that I've got some congruent angles here. These are corresponding angles. They are congruent. I've got these congruent because they're corresponding angles. I've got two similar triangles here, which means that I can set up some proportions. I've also got my side splitter theorem going on here as well. So I'm going to start with solving for X, and I'm going to use that side splitter theorem to do so. So I can set up 12 over 16 is equal to, and then the side across from the X is 8 over X. So I'm going with this one over this one equals this one over that one. Beautiful stuff. There are a couple ways to set up with the side splitter theorem. This is one of them. And now I can cross multiply and solve, but I think the first thing I'm going to do is I'm going to simplify. I can divide both of those by 4. So I'm left with 3 over 4. And now when I cross multiply, I'm going to get, let's see here, 3x equals 32. And then divide by 3. Well, that's not going to simplify, so I'm just going to have x equals 32 over 3. Done with x, which is, I'll put back in, EB. Cool. And if we're putting this in a Google form, I would literally just write 32 over 3. That's it. I'm not going to make a mixed number. Mixed numbers are lame, okay? Next, let's solve for y. Now, a common mistake with this one is something like this. We'll do, let's say we'll do 12, and I'll change colors here. We'll do 12 over 20. So I'm comparing this side to that one. And then what people will do is they'll do 8 over y. But here's the issue. You're only taking a portion of the side of that larger triangle. Right now, we're not using the side splitter theorem because that only works with the two sides that are cut by the parallel lines. When we deal with the bases, we'll call them, of these triangles, I have to compare the entire side right here, which would be 20, over y. Bada boom, bada bing. All right, so that would be our proper setup. But the most common mistake is to put 8 over y, only use a portion of the side because we're thinking about it like the side splitter theorem. Let me simplify first. If I divide by 4, I get 3 over 5. So I'm going to get, let's see here, 3y equals 100. So that means that y is going to be, which is CB, is going to be 100 over 3. Cannot reduce that. I've solved for both. We're good to go. Awesome. Wonderful. Just keep that one common mistake in mind there. Don't use the side splitter theorem when we're dealing with the bases. Okay, we have to think about it as similar triangles. All right, in this next one, we've got this trapezoid-looking thing here. We want to find, first off, BD over CE, and then we want to find a couple other lengths there, AE and BD. Now, A, B, C, D, and E, those are all points of intersection there with those parallel lines. We've got a whole bunch of parallel lines. And then the 3, 6, 2, and 8, those are all side lengths of those individual little segments there that are also cut by the parallel lines. Once again, we're dealing with the side splitter theorem. Okay, I can compare across from each other, meaning I can put AB over 3, I can put BC over 6, or I can even put AC over 9. I can combine them, okay? So a lot that we can do there. I'm not going to go through all the combinations. So if we want to find BD over CE, let's see here. BD, I don't have any lengths. I don't have any lengths for CE either. But what if I took what's across from BD? Well, that would be that whole thing. That would be 8. And then CE would be 10. Look at those teacher brackets I got going on there. I know you're jealous. I know you're jealous. All right, so if I simplify this down, I should always simplify if possible. I get 4 over 5. Nice. When it's asking for that ratio, I'm going to simplify, even if it simplifies down to, let's just say the answer was for example. What if it was like 10 over 10? I wouldn't just put 1, I would put 1 over 1 because it is asking for that ratio. It's a 1-to-1 ratio, not just a 1 ratio, okay? So that is a little bit of a weird thing because usually we think, oh, I'm just going to put 1. But since it's asking for that ratio, leave it as a fraction, even if it's 1 over 1. Okay, on to part B. If CE equals 6, find AE. And I'm going to take some of this stuff off. Okay, if CE equals 6, so go with a different color now because changing colors is fun. CE equals 6, find AE and BD. All right. So, well, what does this mean? Well, I can compare, like to say it like that, 6 to the side that's across from it, which would be from here to here. That's 10. And then if I want to find AE, well, AE is this whole thing, so I'll call it AE. But what's the whole thing on the other side? So from A, the point across from A, all the way to this one here, that would be, it looks like 19. Poor number choice. All right, we got some odd prime numbers. Ooh. All right. So if I divide here and here, I'm going to get, let's see, we can reduce by 2, so I'd get 3 over 5. And now I can multiply, cross multiply that is. And I will get, let's see here, 3 times 19 is 57 equals 5. And then I'll just put AE in parentheses. That's fine. It's a little weird, but we don't have a whole lot of algebra to do. And then I'll divide by 5 on both sides. Lovely, lovely. And I've got, we'll just say AE equals 57 over 5. That'd be like 11.5? No, 11.4. Something like that. Whatever. Okay, cool. But I'm going to leave it as an improper fraction. If it asks for a decimal, then I'll just pop it in the old TI-84. Yo-ro. Okay. Let's see here. Next, we want to solve for BD. I'll change colors again because I'm crazy like that. So I can use the same 6 over 10, right? Because I know that CE is 6, and across from that is 10. And now, if I want BD, well, we're talking about this side here. I'm going to compare it to what we have across from it, cut by those parallel lines. I'm going to have BD over 8. So we'll simplify this down to 3 over 5. And I'm going to end up with, let's see here, 24 equals 5 times BD. So BD equals 24 over 5. It does not ask for decimals, right? So it's really my choice here. I'm going to leave it as an improper fraction. It's the least amount of work. Cool. Fantastic. Wonderful. So again, on this one, we're using the side splitter theorem. We're comparing the sides across from each other that are cut by those parallel lines. It divides it up proportionally. I love it. That was some really fun, fantastic stuff right there. Wasn't that fun and fantastic, Mr. Ernst? He's giving me a thumbs up. He's drinking some coffee right now out of his fancy Yeti.
Yes, sir.
You are high class with that Yeti.
I try.
You do try. Doesn't always work out, but this time it did. Good work. All right. Application time. We got Post Malone is posting up 20 feet from a lamp post. If Post Malone is 6 feet tall, I did actually look it up. That's his actual height. The internet said so. And he casts a 10-foot shadow. How tall is the lamppost? I think we should draw a dope picture of Post Malone. I'm going to pause. A couple more problems here. So we have find BC if AD bisects angle CAB. AB equals 8. I'm going to jot this down there now. AC equals 12. And BD equals 6. Okay. And we know that the angle is being bisected. There are times where we're just given a diagram already labeled like this. There's times where we're given words. There's times where we're given a perimeter of the overall triangle and a couple sides, and we have to solve that. So there's a lot of different variations of this one, but the setup is the same. You just have to be able to identify that. So what I have here is I want all of BC. But if I were to just go ahead and solve for DC, we'll call that X, I could use that to finish out the problem, and it's going to be a little bit cleaner in my proportion because I'm going to have 12 over X equals 8 over 6. That angle bisector, right, cuts those sides proportionally, okay? So this is a nice, wonderful, fantastic little proportion that we can set up in this particular situation. I'm going to reduce this down to 4 over 3, and then I'm going to go ahead and solve. So I get 36 equals 4x, so x is equal to 9. So if this equals 9, the overall length of BC is what we wanted, gives me 15. Love it. Fantastic. All right. Good stuff, good stuff. So yeah, I can give you this type of problem in many different ways. I'm going to give you one of the Ed puzzles to try right now, and then we'll see how you do. Last problem here. Yep, last problem indeed. We've got a beautiful couple triangles here. We've got DE is parallel to CB. We want to find the perimeter of the trapezoid BCDE. Okay. Now, we've got these fun little x plus 7, x minus 1, these little expressions for our lengths, right? AD is 10, AE is 6, DE is 9, and then we got DC is x plus 7, and EB is x minus 1. What? Okay, well, let's see what we can do here. First off, if those lines are parallel, I can use side splitter theorem because it cuts the sides proportionally, right? It cuts these two sides proportionally. So I could set something up like 10 over 6. I've been using 10 and 6 quite a bit here. And x plus 7 over x minus 1. I'm going to reduce to 3 then. And now I'll cross multiply. So I end up with 5 times x minus 1, which would be 5x minus 5, equals, and then 3x plus 21. If you need to, write it out first and then distribute. So let's see, we got 2x is equal to 26. So x equals 13. And when I plug this back in, I'm going to get 20, and I'm going to get 12 for those two lengths. Okay, so right now, for my perimeter, I've got 20 plus 9 plus, bless you, Mr. Ernst, plus something. I got to find CB. I don't have that yet. How am I going to find CB? Great question. I'm so glad you asked. All right. So I'm going to leave a little space below here to do the rest of that math, but we're going to get to finding out CB here. Well, I can't use, as we already know from earlier problems, I can't just use side splitter theorem on this because it's not one of the sides that's cut by a parallel line. It's one of the parallel ones. All right, so it doesn't set up the same way. But let's see here. I could use my similar triangles to figure it out. Now, it's up to you how you want to set this one up. If you want to use 6 over 9 or 10 over 9, just whatever you do, make sure you set up the rest of it according to that same pattern. So if I do 6 over 9 equals, then I would do the whole side of AB, which would be 18, over, and why don't we just call this y down here, since I haven't used the variable y yet. And now I can cross multiply and solve. Right? The same could happen if I did 10 over 9. Then I would do 30 over y, because that's the AC length. But I'm going to go ahead and reduce to get 2/3. And now I can cross multiply. I'll get 2y equals 54. So y is equal to 27. And now I can add in that 27 there and get my perimeter. And there we have it. We've got ourselves 68 for my perimeter of trapezoid BCDE. I could ask for the perimeter of the entire big triangle. Whatever, right? There's multiple questions I could ask here. I could just ask for the length of CB, right? You'd have to still go through that same process to get there. You'd have to figure out what X was, find those lengths, and then set up another proportion. So in any event, it's about the same amount of work whether I ask any one of those 3 questions. Perhaps I'll ask one now in the Ed puzzle because I'm just crazy like that. All right. Thank you guys for tuning in. Have a wonderful, wonderful day. America, freedom, rock and roll, Costco, Yo-Ro, you only round once. And of course, follow Riverdog Jenny on the gram. Right, Mr. Ernst? Right.